Hello, good morning to everybody. Hope my voice is clear.
Yes,
Actually,
yes.
the internet here is not very clear. As a result, probably in between the voices, maybe it gets broken.
Mhm.
So SPD is as all of you know, SPD is actually a very important component in the electrical panel or in the electrical installation, because this is the only product which is going to protect the electrical installation from transient over voltages due to lightning or from switching. Basically, it keeps the insulation levels at a very high level, or the transient over voltages will pass through the device, and this device gets degraded. As a result, the installation's insulation strength will be kept for a long time. So basically, you get a lot of the life of the electrical installation will be enhanced to a large extent by using SPDs. After all, SPDs are made either by a spar gap or a GD tube or an MOV. If we look at the type 2 SPDs, the actual component which is used inside is a simple MOV. You can buy it from the market for 20 rupees, maybe for a three phase, for a line to neutral application. A 230 volt MOV probably is 30, 40 rupees onwards you can buy from the market. And nowadays the trend is people, a lot of components or products are coming from China with very cheap MOVs and put it into the line. Actually, the whole standardization of SPD is becoming very important nowadays, because SPDs are becoming a reason for fire in panels. Uh, if you look at the technicalities of, say, for example, a type 2 SPD, more than the component which is going to use or going to work as the discharge element, more safety measures are being integrated into the SPD. A type 2 SPD, conventionally, it has got an MOV and a thermal disconnector. In the sense, once when the temperature goes beyond 80 degrees, there is a spring mechanism, and the temperature, due to the higher temperature, the SPD is disconnected from the mains. But now, once when we install this SPD into a line, at the end of life of the SPD, most often, probably after 7, 8 years, or maybe about 15 years, the SPDs are catching fire. As a result, a lot of installations are getting into trouble. So nowadays, the standards are made in such a way that the safety hazard or safety is given more importance. As a result, both, I will just share a screen and show you two standards which are probably very important with respect to the selection of SPDs. The first one is 61463 part 12. This is a standard which is published during 2020, which explains about the selection and erection of SPDs for power system 230 400 volt. And the other standard which is talking about the same subject is 60364 part 5. One moment. Yeah, 553. This also talks about SPDs which has to be selected or which has to be used. The conditions can be used for selecting and erecting SPDs. I just show some of the clauses which has to be taken care while selecting and erecting an SPD. The first one, as you can see here, selection of voltage protection level as a function of equipment rated impulse withstand voltage. Most often, SPDs are installed with long wires. Even though we are repeatedly telling the users to use shortest wire length, due to practical reasons, due to a fuse in between, sometimes due to, there is no space in the panel board. As a result, SPDs with longer wires are used. And for your information, these SPDs, of course, will not have any effect in the network. It's just like a dummy, keeping something in your network and believing that it will protect your electronics. Technically, it won't do any job. So these important informations are included in these lines of the IEC standard. Of course, we have included this in the National Electrical Code as well. Then several selection methods are explained. I don't want to. I will show you some important measures. Don't want to go through the whole thing. For example, selection of SPDs with regard to the short circuit current rating ISSER. In general, a short circuit current rating ISSER of the SPD, as stated by the manufacturer, shall not be lower than the maximum prospective short circuit current at the connection point of the SPD assembly. So a new concept which is included or which is made in the standard is SPD will have a backup fuse. The SPD and backup fuse together is called as SPD assembly. So the SPD assembly shall have a short circuit withstand which is more than the expected short circuit level of your panel board. So here actually, for example, some SPDs, type 1 SPD, which can, the manufacturer says it can have a, let's say, for example, 500 amps fuse. So the combination of the SPD and the 500 amps fuse together, it can handle only sometime 20 kiloampere short circuit current. And if you connect this SPD and the fuse in your panel board at the incoming, where probably the short circuit level is much higher, let's say 50 kiloampere, we are actually risking the whole panel. So the safety is gone. So this is a very important subject which you should take care. So that means the person who is selecting the SPD, he has to be technically knowledgeable to do the job. The second one, in general, the follow current interrupting rating of the SPD, if declared by the manufacturer, shall not be lower than the maximum prospective short circuit current at the connection points of the SPD assembly. This is applicable for a spar gap based SPD. In a spar gap based SPD, there is a parameter called follow current. The follow current rating has to be at par with the short circuit level. Here also, we are finding in several cases, the follow current rating of the SPD is 25 kiloampere and the short circuit rating of the panel is 50 kiloampere. So these are actually danger. But most often, once when we tell the panel builder, please don't use it because this is compromising the quality of your panel, they end up with saying that no, the consultant has or the designer has included this SPD and it is an economical model, so we go for this. Most often, the users are not really taking care of such measures. So just the idea of showing these the lines are to inform you that SPD, of course, what is inside the SPD is just sometime an MOV which can be bought even from the market. But as an SPD assembly or as an SPD, a lot of safety features are included in the SPD. So we are paying actually for the safety features, which is inbuilt in the SPD. Now, as Mr. Vijay was explaining, continuity of supply and the continuity of protection. SPD has to be actually selected based on continuity of supply, continuity of the protection or continuity of supply. Means the question is whether you need protection at the end of life of the SPD or you need the power supply without interruption at the end of the life of the SPD. So these are very much included in the latest standards. One moment, I am just showing you the standard surge protection selection and erection, which is a new standard. So this standard has got, it is one of the biggest standard which is published in recent days. It has got about 215 pages. So a lot of new informations are shown here. For example, if you wanted to use an SPD, let's say V-type connection, how to make the V-type connection. If you use it in a panel board, how to make it and how you can reduce the length of the wire, and all such informations are included in the standard. So the most important point is the SPD is not probably SPD looks like a small component in the electrical installation, but it's a critical component. Most of the installation, of course, we don't even use SPD. So using SPD is actually a mandatory requirement because it enhances the life of your electrical installation. Without SPD, of course, the transient over voltages will deteriorate the insulation and the life of the installation will be going down. So the question is whether you want a long life for your installation. If you want a long life, of course, you need SPD. And the second is, if you are using an SPD, how safe this SPD should be. So safety of SPD, as I said, is very important. Otherwise, this item is going to, or this component is going to create a problem in your network. And these are, in our last webinar, we explained about the importance of wire length, and this time the importance of backup fuse. Backup fuse means the fuse which has to be used along with the SPD. Of course, every SPD requires a fuse. And most of the SPDs available in the market are tested with the HRC fuse. But once when we inform or once when we tell the panel builder to use HRC fuse, they say, no, my panels are fuseless, so we don't use HRC fuse, we use only MCB or MPCB. Actually, these are violation of safety rules. So if the manufacturer in his test report, let's say, for example, VDE or KEMA test report has tested the device with HRC fuse, you must use a HRC fuse. Don't try to change to MCB, MPCB and all. Manufacturer, the salesman can claim anything. Salesman say that, I will give guarantee, but after 15 years, this device is going to help you after 15 years and nobody knows what is going to happen after 15 years. So we have to be very careful. So with this, I would like to make a conclusion. SPD is a very important component. Of course, it's a new component in the electrical network. The usage of SPD is quite less in our nation because most often, people think that even the installation can work without an SPD. Then what is the need to put an SPD and increasing the cost of the installation? The answer is, if you install an SPD, your electrical installation's life will be much more. So over to you, sir. Mr. Dominic.
Oh, thank you, sir.
We have, I think, a lot of questions today.
Yeah. So if you install SPD, the life is longer. So I think Shishpal Negi's question is answered here. What would be the difference of impact in case of wire versus bus bar? Why we are saying that 0.5 meters wire shall be used, nothing about bus bar? Would you like to again highlight something, or should we skip this?
Yes, actually, I tried typing the answer, but by mistake I clicked online, answer online. So then I could not type. Okay, anyway. The question is, what would be the difference impact in case of wire versus bus bar?
Yeah.
Actually, if we use a wire, the tendency of increasing the length and bending the wire is much more. As a result, the effectiveness of the SPD is gone. Whereas if you use a bus bar, the first advantage is these SPDs, which was explained in the last webinar, they can be mounted directly on the bus bar. If you put directly on the bus bar, the wire length itself has become zero. The effectiveness of the SPD is very high. So in comparison to wire length, of course, the SPD bus bar mounted can give a much better performance. This is the answer.
So Haribabu Nara, sorry, sir.
Yeah, Mr. Nara. Yes, please.
Yeah, Nara, please mention the minimum wire size to connect SPDs from bus bar or fuse for a 50 kVA system.
Yeah, 50 kiloampere short circuit breaking capacity system. Mr. Nara is asking what the wire size which has to be used for this kind of a device. Mr. Nara, if you look at the size of the wires which has to be used for the purpose of handling lightning current or surge current is quite less. It may be 16 square millimeters or so. Whereas if your fault current is much higher, so you must use a higher size wire or higher size bus bar. So much bigger. We can calculate it because first we need to understand the type of backup protection you are using. Based on the backup protection, we have to find out the temperature which can rise and the disconnection time, and we can calculate the size of the bus bar or wire. Of course, it need a much bigger wire.
Ramashish Banerjee is asking where to install SPD, at main DB or sub DB?
This is SPDs are required at the main distribution board as well as a sub distribution board. So the question is, if your building doesn't have any lightning protection, of if there is no overhead line connected to your building, then a type 2 SPD is required, but at the main distribution board. So first is at the main distribution board. Then if you have a larger building, of course, at the sub distribution board also you need SPDs.
Oh, Tanmay Pandya is asking what is TOV condition?
Yes, actually TOV stands for temporary over voltage. So there are several conditions with which temporary over voltages can exist. One of the condition is in case of neutral isolation in a three-phase system. Of course, there can be a higher potential between line and neutral, which is up to 400 volt for a longer duration. The second case, probably in case of a in case of a short circuit, in case of a fault on the HT side of the transformer, and if the TOV at the LT side is not taken care as per the clause 4.5 of IS 732, of course, up to 5 seconds, a higher potential can come in the LT side between line and earth. So there are several conditions with which a temporary over voltage can happen. The SPD which you are installing must be able to withstand those temporary over voltage.
Okay, move on to Anand Sinha. Thanks, but 1 millihome homes is as per. Sorry, sir.
1 mega ohm.
1 mega homes is as per IEC, but hospital nowadays are following ANSI. As per ANSI should be 100 mega homes. So is 1 mega homes is safe?
Mr. Anand Sinha, for India, ANSI is not applicable. ANSI is an American standard. We are in India. So Indian standards are applicable. And for India, there is a standard which is published recently called as National Electrical Code of India 2023. So 1 mega ohm in a normal electrical installation is enough to meet the requirements of the Indian standard. As I said, the ANSI is not applicable to India. Probably if you are referring to hospital in some other nation, of course, you should refer to ANSI if ANSI is accepted in those standards of those countries.
More to Bal Chandra Agarwal, which is preferable as backup protection, fuse or MCB, and why?
Actually, we have to look at the manufacturer's catalog, or sorry, not the catalog, manufacturer's test report. You find out the device which is used as a backup protection in the test report. If the test report says HRC fuse, then you should use HRC fuse, and if it's MCB, you can use an MCB. But then, most important, what is this test report? There are manufacturers in India, or manufacturers or suppliers of SPD in India, those who actually buy from China, put a nice brand name, create a document. If you ask for a test report from a particular laboratory, of course, within 10 minutes, they will give you the test report and claim whatever you need. I'm not talking about let us say this is a low class SPD. I'm not talking about a low class SPD. If you go for a high class SPD, probably, let's say, for example, tested in a VDE or in a Kema laboratory. So those you look at the test report, find out the protective device which is used as backup protection, and you select based on that. Why I make this statement is most of the time the panel builders are stressing as a supplier. Panel builders tell us that no, your competitor says his device can be used with an MCB. Why you are insisting for a HRC fuse? As a result, after a few discussions, sometimes there can be chances of violation. So this is not correct. We should follow what is written in the test report.
Moving on to Anand Sinha, he seems to be electrical safety auditor. Is talking about hospitals are even bypassing ELCB, RCCB, saying that even small leakage trips the supply. So it's a big challenge that he's asking. How do we counter that?
Actually, ELCB and RCCB will not unnecessarily trip if it is selected and erected as per the recommendation. Now, if the selection and erection is made as per the recommendation, and if these devices are leaking, it means that there is a faulty equipment. So rather than bypassing the ELCB, the customer, they have to find out the leakage in the device, and they have to rectify the leakage. That is the correct way. Or in a hospital medical location where continuity of supply is mandatory, you can go for an unearthed system. Both are possible. Unearthed system, of course, you don't need to worry about the disconnection or tripping of such devices.
Alpesh Pandya is asking the whole presentation. Alpesh, if you go to Mr. Gopakumar's blog or CAPE or SOLVE, so you will find all the previous presentations, in fact, last presentation. So it's available in the blog. You can follow Mr. Gopakumar in his LinkedIn and his Facebook and his website. It's all the information you wanted for a group study. You can definitely use this as information. So Balchandra Agarwal, will Backupfuse F2 always blow whenever SPD conducts?
It is not like it always blow. The Backupfuses, its a real application is at the end of life of SPD, because SPD is not eternal. At some point of time, it will fail due to degradation, deterioration, or probably due to a higher surge current. So once when the end of life of SPD, of course, the fuse is required.
So Balchandra Agarwal again is asking, in US, why SPD tested to class 1 test are not required? Is referring to IEC Annex IEC 616.
Yeah, they actually they follow a different concept. They don't follow the concept of this 10 by 350 microseconds impulse current. So class 1 test is for a 10 by 350 microsecond impulse current. So since they don't follow it nationally, they have not accepted the claim of 10 by 350. They go for the type 2 SPD.
Okay. Going to Ramesh Banerjee again. Sir, in case of installing AC, can we replace voltage stabilizer with SPD?
Actually, the purpose of both of these devices are different. SPDs are to reduce the transient or disturbances, high voltage disturbances, short duration high voltage disturbances in your network, whereas stabilizer is for a different purpose because it stabilizes the voltage. So you
Yes.
cannot change both. But nowadays, most of the cases, our voltage supply is more stabilized, and you don't need actually a stabilizer. And number two, as we always say, stabilizer actually add the impedance in between, which actually don't allow the MCB to trip in case of trouble. So we have to be very careful in using the stabilizer.
That's a good
But
advice.
including my house, we use we use
Everywhere.
our stabilizer because the
Yeah.
supplier says if you don't put a stabilizer, I won't give guarantee. So we have to
So
actually change those concepts.
maybe 5-10 years back, stabilizer in very high sales, and fridge, refrigerator, TV, everywhere you want to use stabilizers. And nowadays, it's not, they don't even insist for it. So Parthipan is asking how to check existing SPD's health.
Mr. Parthipan, there are devices available. There are test equipment available. We have a test equipment with which all kind of SPDs, type 1, type 2 SPDs can be tested. It actually gives a small impulse voltage and gives the output of the clamping voltage or voltage protection level. It's possible. There are devices available.
Okay. Balchandra is asking a technical question and is asking whether it is correct. Would you like to read out, sir? It is too technical.
Yes, class one tested SPD which withstand the partial lightning current with a typical waveform of 10/350 microseconds and require a corresponding impulse test current. It is different 8/20 of IEC 61643. Mr. Agarwal, please note that 10/350 is in the laboratory, it is produced as a 8/20 wave shape. Whereas in class 1 test, the actual impulse current is 8/20, but the energy, the specific energy and the charge, that means the capacitor which is producing this impulse current, the size of the capacitor is bigger, its charge is bigger. So the energy which is going to flow through the SPD during this duration is much higher. So practically, even though the set shape is 8/20, but after the impulse, you can see that due to the higher charge, the set impulse current wave shape has changed. Actually, you don't need to get complicated with these wordings from the standard. The 61643 part 11 is not for an user. That is for an SPD manufacturer, because that is the test and performance requirement. So SPD manufacturer will take care of it. You have to refer part 12, selection and erection of SPD.
Okay, more again, the question from Balchandra is building without LPS also shall be provided SPD.
Yes, of course.
Yeah.
Yes, of course. If you have, for example, an overhead line, probably the overhead line can have a direct lightning strike and your equipment can fail. In that case, you need a type 1 SPD at the mains incoming. And if you don't have external lightning protection and if you don't have an overhead distribution line, then you can go for a type 2 SPD at the mains incoming.
Sir Abdul Majid is asking, what type of SPDs are used for DCS PLC panels and where is to be connected?
What type of SPDs? Yeah. These, you see, there are different kind of SPDs. Type 2 SPDs are there for power supply. If you talk about control panels, PLC panels, if you have communication wires, then we have to find out the type of communication, whether the communication is operating in common mode or differential mode, whether functional earthing is there in your panel, whether the frequency of this particular transmission, the voltage of this particular communication. So based on all these parameters, we have to select SPDs. One of the subject which is becoming important nowadays in these DCS and PLC panels are functional earthing. Most often we put an SPD and protect the protective earthing of the panel. We neglect the functional earthing of the panel, which is sometimes a separate terminal. As a result, the failure continues. But of course, we have the expertise. We have to really look into your single line diagram. We have to go through the entire technical parameters of the panel, and we can select the appropriate protective measure. Thank you.
Rajkumar, does SPD require any protection devices on its circuit?
Does SPD require any protection device on its circuit? Of course, if you want the continuity of supply, then you need a protective device. And if your panel board, for example, the circuit fault current is very high, then also you need a backup protection to ensure that the SPD is failing safe at its end of life.
So Satya Narayana is asking how to assess the life of SPD or the time for replacement of SPD.
Actually, if the SPD is of a standard quality, standard tested device, then you can expect an average of 20 years. If it is selected and erected appropriately. 20 to 25 years would be the life of an SPD. But again, if you put the SPD closer to a capacitor switching panel, then of course the life will be a little bit lesser.
Sonu Sharma has a doubt. How do you check whether SPD is working properly?
Actually, this is a very important subject. You have to only trust the manufacturer. So manufacturer, as I said, the manufacturer's test report is the only way which you have to trust. So as I said in between, it is very peculiar in India. Some companies go to China, buy some component and put a very nice label, and whatever the test report you are asking, within 10 minutes, 15 minutes or 2 days, the test report is in front of you. So please don't trust this. You use only VDE or KEMA approved devices. Go to VDE or KEMA websites. Online, these certificates can be viewed. Check whether these certificates are genuine or not, and then select an SPD. Don't trust the test certificates or test reports which is circulating in the market from test laboratories across India. Unfortunately, there is no laboratory in India who can test an SPD, but test certificates are there, available a lot. So be careful.
So it's a very, very strong message that we are giving to the audience. Don't trust that what is there in the market from Chinese and all that. So you also gave a hint to that. There are way of checking through website of KEMA.
Yeah, it is actually it's a pity that once when we come to electrical safety, we are putting a lot of efforts in educating the market, but still the usage of all these spurious products are there. And if you look at lightning protection and the earthing has become a subject, even though it's a very, very important subject. You can find thousands of experts and thousands of companies making and selling these devices without any quality check, because nobody bothers about these devices. Lightning protection most often is used just to convince somebody, like the electrical inspector. He's asking some questions, so put something so that his requirement is closed. The seriousness of these devices are not made. This is the reason. For example, if you look at an MCB, you cannot find a lot of low class MCBs in the market. Whereas with respect to SPD, you can find hundreds and thousands of SPD. For example, you just Google, you can find SPDs in the online stores, such as I don't want to name. Online stores are selling hundreds of SPDs, and out of these hundreds, 99% is made in our neighbor country and put a label and create a nice document and a video and sell it. This is not. And whatever the test report you need are immediately provided. It won't work. Be very careful. This is a strong message, as you said, Mr. Dominic, I want to give. Thank you.
Yeah, I think spurious material, electrical is a big menace in India. If you go to Delhi, Chandni Chowk, you will get, in fact, you'll be surprised, even Cape material are duplicated and kept in the shop there. So there has to be a barrier, there has to be a checking method. How do we differentiate between the original and duplicate, or how do you confirm the test certificate that has been given by these suppliers? So I think NFE could address this in the future of the various events that you have planned. So moving on to Parthiban, difference between SPD and lightning arrestor.
Yeah, both of the names of the earlier name is lightning arrestor, but the correct name for the device used in the power line is SPD. Lightning arrestor is a name which is used for several different purposes. Sometimes a high voltage surge arrestor is also called as a lightning arrestor. Sometimes the rod, air termination rod, is called as a lightning arrestor. So SPD is the correct word.
Nursing how is checking where when we have a good grounding, do we still need a surge protection?
Yes, of course. A good grounding ensure that your installation is safe against earth fault or earth leakage, whereas as SPD ensures that your transient over voltages are limited. As a result, your life of your installation is much more. Actually, one important point is SPD is a product which is most of the time its usage is not felt. So it's like a passive device. It will be like silently it is sitting in the circuit and keep doing its job. As a result, even if a spurious SPD is used, nobody realizes that it is whether it is working or not. This is one of the advantage for the low class products sold in the market, because nobody knows whether it is working or not. Some of the SPDs, a few years back, I bought a set of SPD from the market. We were just trying to find out what exactly inside. Surprised to see that inside its casing, it contains nothing.
Oh,
it was an empty. It was a beautiful casing, very beautiful casing. Two wires goes inside, and inside is a simply, it's a sealed with a resin, and inside is nothing. So we have to be very careful.
Playing with such a critical equipment and also life. So these are the challenges that how do you overcome? How do you trust it? What kind of verification, tested, certificate? It's a big challenge in India. How do we get a quality product and how do we check? So you're able to break it and see, but how many people can do that? And they'll say, if you break the seal, no warranty. So people are also afraid to even break the seal, which says do not open, warranties not. So these are the questions. Anyway, we have 4 more questions, sir. We'll try and complete. It's almost 12:32. We are taken 2 minutes more. Anonymous, our equipment is connected to UPS. Do we still need surge protection?
Yes, of course. So whether you have a UPS or not, of course, surge protection is required. Sometimes SPD is required even to protect the UPS.
Okay, Sonia Mittal, I think we have answered this question that by other member who asked. So I move on. Naresh Babu, the last question today. Is there any impact in SPD for doing IR test?
Of course, once when you do an insulation resistance test, SPD has to be, or SPD must be removed from the circuit. Then only you should do. And that instruction is generally available as a sticker along with the SPD. So you should be very careful in this particular case.
Wonderful. So with this, we end the question answer session.